Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice in using decision criteria to resolve a hypothesis test. Let's get started. So we're going to go back to this example that we saw in previous mini lectures with this XORT method that is claimed to provide, greater probability of having a girl than a boy. So this means that our critical region's in the right tail of our distribution. How do we know that? Well, go back to our alternative hypothesis that we had earlier. The null hypothesis, of course, a statement of equality. And then remember how we just took the claim and we made that our alternative hypothesis because the claim has no semblance of equality to it. So we can just adopt that as our alternative hypothesis. So look at the inequality symbol in the alternative hypothesis. This tells us what type of test we have. Because this is a greater than sign, it's like an arrowhead pointing to the right, and that symbolizes we have a right tail test. So that means our critical region is in the right tail of our distribution. So that's going to be the region of rejection for our hypothesis test, in the right tail of the distribution. Now, let's say we want to use the p-value to complete the hypothesis test. In that case, we have a test statistic which we calculated in an earlier mini lecture, z equals 1.6, and that's going to be the border for the area under the curve that is the p-value. It's the area on the right side of the distribution, the area in that right tail, because we have a right-tailed test. And the value of that area is 0.0548. We can get that easily by using the normal calculator in StatCrunch, or if you want, you can use your z-score tables. That works just as well. Just remember, if you use the tables, typically the value you get for the area is going to be the area to the left, because here we want the area to the right. You're going to have to take the complement of that area you find from your z-score table. Either way, you get the same number for that area in the right tail of our distribution, 0.0548. That is the p-value. We compare that p-value with our significance level. Now, if you remember from the prior mini lecture, we weren't actually given a significance level and we didn't select anything. So at this point, we can select something. And because nothing was specified, we're going to make the safest assumption we can make, which is to say, our confidence level is 95%, significance level alpha 5%, because that's by far and away the most commonly selected value, and that's why it's the safest. So because the p-value 0.0548 is greater than 0.05, that area for the p-value is greater than the area for the significance level. That means we can't fit the p-value inside the region of rejection. That means we're outside the region of rejection, and therefore we're going to fail to reject the null hypothesis. So we've got the p-value area, and we've got the critical region area, the region of rejection. And the p-value is greater than the critical region. So we can't fit it inside the region of rejection, and that leads us to fail to reject H0. Alternatively, if we want to use the critical value for our hypothesis test, we can do that. We know that alpha level being 5%, we're going to have a critical value of 1.645. Okay? Again, we can get that from StatCrunch, or we can go to our z-score tables and get that value out. We can there compare the test statistic that we calculated earlier, z equals 1.6, with our critical value 1.645. So, because the test statistic is less than the critical value, for a right-tailed test, that means we're outside the critical region, and therefore we're going to fail to reject the null hypothesis. In these instances, I often find it easier if we just draw a picture. So here's my distribution with the critical region in the right tail of the distribution because I have a right-tailed test. The critical value is the boundary for that rejection region. Notice my test statistic falls just outside that region of rejection. It doesn't matter how close or far you are from being in or out of the rejection region. The only thing that matters is, are you in or are you out? In this case, the test statistic is outside the region of rejection. Therefore, we're going to fail to reject the null hypothesis. Notice we get the same conclusion regardless of which pair of standards we're using for our comparison. So it doesn't matter whether you're comparing the p-value with your alpha level or you're taking the test statistic and comparing it with the critical value. You're going to get the same conclusion coming out regardless of which way you do it. And if you don't get the same conclusion, then that says something is seriously wrong, because you should get the same conclusion coming out. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.